turn in the bell ringer, correct? Yeah. So this is our quick little review of what we did on Friday for the beginning of the day. And then we're going to finish this lesson and move on. So, because we should have done 2, honestly. It says, what's the length of RS? Well, something that you learned was that if U is the midpoint, and that's what it says, right? U is the midpoint, then it's in the middle. So if this distance is 12, what's this one? 12. Okay? And we also know that 2x equals 11, right? 3y equals 15.9. Okay, back to this, boys. Y'all quit talking. I'm going to move y'all. So the length of RS, since I know this is 12 and this is 12, what's the whole thing? 24. Did everybody get that? Okay. Now it says, what's the length of X? Well, I know V is the midpoint, so 2X equals 11. Did everybody get that? 2X is equal to 11. So I'm going to write that. How do you solve for X? You would divide by 2. And did y'all get 5.5? I think so. Okay. Close to 6, yeah. Okay. What's the length of Y? So I've got these 2 pieces. We know that this half equals this one. So 3Y equals 15.9. What do I do to solve that? Divide by 3. So I would get 5.3. Are we getting this? Yeah. Okay. Then UW, all right, here's something. Let me write this down. If this is 11, what's 2x? It's also what? 11, right? So this is 11 and this is 11. That whole thing is what? 22. But I know that UW is just half that. What's UW actually going to be? 11. Did y'all get that? Okay. Nope. If this is 11 and this is 11, that whole side is 22. What's half of 22? 11. The length of UW is just 11. All right. Are y'all kind of seeing a pattern with that? So look, if this is 15.9 and this is 15.9, what's UV going to be? 15.9. I could have added those together and divided by 2, but again, I would get 15.9 for UV. Any questions on how I'm getting that? No? Yes? No? Okay. Those are the rules and things that we learned about on Friday. So let me write this down. Another one. I have a bunch of extras of those. Okay. So on our worksheet, y'all did 3 through 23. Y'all did all of them. I haven't graded them yet. So I want to go through some of these on the back to make sure we're understanding this, okay? It says that the measure of angle A is 70. Find the measure of angle BDE. So there's a rule that we haven't learned yet. We did all that. We did all that. Let's see. I don't know. All right. Basically, if this is 70, we know that this is a midpoint, but this is also going to be 70. It's there because the triangles are congruent, okay? Or kind of like the angles are. Okay, so let's look at BED. If BED is 73, this little angle right here is 73. What's the measure of angle C? Anybody tell me? 73. Okay. It's just something we're going to know. I wish I could see where this rule is. They say nothing about angles in here. Let me see if it's in the next lesson. No. So you're just going to know that these angles are congruent whenever you have this mid-segment. Okay, if DE is 23, all right, this line right here is 23. What's AC? Do y'all remember how to find that? 46. You just double it. Okay, this one's 46. Okay, if AC is 83, okay, let's think now the longer one is 83. How do you find DE? Divide by 2. You go backwards. And what's 83 divided by 2? 41.5? 41.5 would be my answer on that one. Okay, do y'all understand that? Yes, no? You're either taking half or you're multiplying by 2. The angles, that's something we didn't go over on Friday. They're just congruent. Okay, number 28. Now it's talking about a distance of a lake. So you'll have one of these, which it'll be a long while before we see a study guide or a test. But you'll have a problem like this where you'll find the length of a lake or distance across the lake. So that's a question mark. It's not a 7. If this is 6.5 miles right here, what's the length across the lake? 13. You just double it. 13 miles. If this is 5.8 miles, how do you find this distance? Divide it by 2. Can somebody tell me 5.8 divided by 2? Anybody? 2.65. Somebody tell me. What'd you get? What's 5.8 divided by 2? 2.9. I got it wrong. Okay. Then on this one, we know that this is 7 kilometers. That is a question mark, not a 7. So I would what? Divide it by 2, and that would be what? 3.5. Okay, and I know I can do this when these two parts are equal. See that this part is equal to that part. This part is equal to, this part's equal to that one. Those are mid segments. That's the only reason I can do this. If it's the mid segment, then you can double it or half it. Are we good with this? Yes, that's pretty much the whole lesson. These are just some random problems, same kind of thing. But y'all already turned in 5-1, so I don't need that from y'all. Put this over here from Madison and Will. Now, 5-2, we're moving along to the other part of the lesson that you were supposed to learn on Friday, but we were busy. We're looking at perpendicular and angle bisectors. What does it mean if something's perpendicular? Yeah, 90 degrees. Perpendicular means that it makes a 90-degree angle, and bisector, it means it splits it into 2 equal parts. If it's an angle bisector, it splits the angle into 2 equal parts. Okay, if it bisects a side like this, or a line, it splits it in 2 equal parts. So that's what those things mean. So your little theorems, it says that if this line here is perpendicular to AB, and I know that those 2 sides are equal, then I can draw a triangle and they're going to have equal sides. Do y'all see that? So if I have this picture here, I know that these are 90-degree angles, and these 2 sides are equal. Then do you see how you can draw the triangle and those 2 sides are equal? Yes, no, maybe so. Basically, it's because of side angle side, y'all. Okay, look, let me just draw a picture without theirs. But that's why you can do that. Sorry, that's some other math. So they're saying if I have that these are both 90 degrees, okay, and these 2 sides are equal. If I draw and finish out these triangles, are they congruent? Yes, because this is reflexive property. The triangles are congruent by what? Side, angle, side. So I know that those 2 things are congruent. That's all it's saying, something I already know. Okay? Then also we can go backwards from that. So they call it the converse of the perpendicular bisector theorem. That's hard to say. Perpendicular bisector theorem. I can say that if I know that I have a triangle and these 2 parts are equal, then if I draw a line straight through like this, then it's 90-degree angles and these 2 parts are equal. Okay, you're just taking it backwards. So we're going to use those rules for a problem in a second. Okay, are we kind of getting that though? 90-degree angles and then equal sides. All right, so this one says, they give us this little triangle right here. Actually, I'm just going to draw the picture so I can write. It's blurry. There we go. If I have my triangle, A, D, C, B. This is 4x, and this is 6x minus 10. And I know these are 90-degree angles, and these two are equal. How would you find x? Using the rules I just told you, what do you know? What do you know about this side and this side? They're equal. That's all we're doing, just using that. If this is 90 degrees and this is equal, if this is a perpendicular bisector, then those two sides are equal. So I'm just going to set them 4x equals 6x minus 10. What would I do to solve? Subtract the 6x. Normally I would move the 4, but I don't want to because there would be nothing left over there. So I'm going to subtract 6x. And I get negative 2x equals 10. Then what? Equals negative 10. Then what? Divide by negative 2. And what does x equal? 5. Okay, now it asks me something else. It said find x. Then it says what's the length of those sides? Can anybody tell me? How would you find the length of those two sides? They're 20. 20 and 20. If I know what's 4 times 5? 20. If I know this one's 20 without even doing anything, what's this one? 20. But you could still plug it in and you'll get the same answer. Does everybody understand that first rule from the worksheet? Yes? Okay. Let's do another one. It says, okay, if I have this triangle, you just have to remember all these rules. Theirs is drawn way better than mine. Oops. And it is the perpendicular bisector. And again, this is 3n minus 1. And this is 5n minus 7. What are you going to do with those two things? Set them equal. Perpendicular bisector, they're equal. So 3n minus 1 equals 5n minus 7. What do I do now? Subtract the 3n. So negative 1 equals 2n minus 7. Then what? Add 7. So 6 equals 2n. Then what? Divide by 2, and I get n is 3, and I may stop there, or it may say what? What's the length of those two things? So that's part of my answer, but then it wants me to plug it in. You'll have to see what your paper asks you for. So what's 5 times 3? And 15 minus 7 is 8. If this side is 8, guess what? This side is also 8. Okay? So that's problem 1. How do we feel about that? Good? Let me see. I'll do another one before I give you. I'm trying to think. Yeah, and then I'll give you a few to do. Okay. This one says, thank you. All right, they give us a picture. So I think there's one on your test like this where they'll give you a picture and you just draw on there. They want to build a t-shirt stand equidistant. What in the world does equidistant mean? Yeah, just look at it. Equal distance, okay? So they want a t-shirt stand that is an equal distance from the roller coaster and the spaceship chute. All right, so what are possible locations for this? So if I would draw like a line through there, okay, and you want an equal distance from those, what do you think it would be? What would a possible location be? Any ideas? So it says what they would do is they would draw, I don't want to draw on here, but like draw a line and kind of find the middle and draw through it, okay? Then you can just draw your triangles and where that's going to be what it would be, okay? So they just say, I mean, that's what I would do. I would just draw, but I don't want to draw my book. I would draw a line through it and kind of find the middle, right? And then draw your triangles and kind of see where that point is. And that would be where I would put it on here. Does that kind of make sense? You're just drawing a picture of what we've been drawing. Yes, no? I don't, if there's one on your worksheet, let me see. I know there'll be one on your study guide. No, I don't see any like that on your worksheet today. When we get to the study guide later, we can draw on it. Okay, the next thing is we'll go ahead and finish it. Angle bisector. What does that mean, an angle bisector? It cuts an angle in half, okay? So what we're going to have, let me show you these two things. All right, if this line right here, if I have an angle and I cut this line through it, QS, so that it bisects the angle, then I can draw these two triangles here. All right, and I'll draw them in a second. And I would know that those two pieces are equal. All right, so let me draw the picture step by step so you can see what I'm saying again. If I have this angle, all right, it's Q, P, and R. All right. Now, if I draw this line through it so that it bisects here and here, that means if these two angles are equal, okay, then I can say that if this makes a 90-degree angle, these two pieces are equal. Does that make sense? I'm drawing some little triangles in there, okay? If these have 90-degree angles and these two are equal, then so are these. Also, we can say that backwards. If I have this 90-degree angle, I'm trying to draw it, and this is a 90-degree angle, and these two pieces are equal, then what can you say about the angles? They're going to be equal. Okay, so it's backwards. You can go either way. So what am I going to do with that? Let me give you a problem. Okay? Do y'all notice that today you're mainly setting things what? Equal to each other. Okay? That's what we were doing all day. Here's my picture. And it says that this is N, P, M, that's R. Sorry, lots of letters. And I know that these two things are equal. So it says, okay, this is 7x, that little line right there. And then this little line is 2x plus 25. How would you find x? What would you do to find x? Do we remember? We would set them what? Equal, over and over again. Okay, if this is equal and these are 90 degrees, these are equal. So I would just write 7x equals 2x plus 25. Then how do I solve it? Subtract 2x. So I get 5x equals 25. Then what? Divide by 5, and x is 5. So it may tell me to stop there, or what else would it probably tell me to do? Plug it back in to find those lengths. So x equals 5 may be my answer, or that 7 times 5. What is 7 times 5? 35. So those lengths may be 35. That might be what it's asking for. Okay? Do we kind of get this? That's the whole lesson for this one. Let me look at your worksheet and see if you have questions. I'm trying to think. Here, let me pause it and I'll hand them out, and then we'll see if you have any questions. Okay, y'all are going to do the evens real quick. If you started with number 1, it would kind of guide you through 1 through 4. It's saying, what's the relationship between LN and MO? Well, it's the perpendicular bisector. Okay, but y'all don't have to do number 1, but that's what it is. You would say perpendicular bisector. Okay, and because of that, it's saying what's the value of x. Well, if I'm only looking at this triangle here, I know that these are 90-degree angles and these are equal parts. What do I know about these two things? They're equal. So then you can find x. Then on number 2, once you find x, that will help you answer number 4. What would you do with that x? You would plug it in. Okay? Yes, that's what we've been doing the whole day, setting things equal and plugging it in. Yeah, solve for x, and then number 4 is you plugging it in. They just separated it into different problems. So y'all are doing all the evens. I've got you started with 2 and 4. There is a picture on here. I know you don't have to do number 9, but this is kind of like one that would be on the study guide or test, and I can actually draw on this one. So it says, they give you a picture, and you've got points A, B, C, and D. Y'all, and it should just be obvious and common sense. Which one of those points would be a good spot for the receptionist to be where it's equidistant from both entrances? Do y'all see this is an entrance and this is an entrance? Which spot would the receptionist desk need to go to? B. Okay, you can just tell. But if you notice, B would make a 90-degree angle, and then these 2 points are an equal distance from that 90-degree angle. That's why. That's the geometry behind it. Then part B says, is that statue equidistant from both entrances? And why? Yes, it is. I know you can just tell, but it's because if this makes a 90-degree angle here, and then what? The entrances are the same distance from that. Okay, it is the perpendicular bisector. That's why. Okay, I hope it's all kind of coming together. Now, y'all can still pick up and do the evens. I do not, I'm going to decide that depending on where we are at the end of class today. Because I'm thinking we may do, if we have time, we may do a little lesson and then a small quiz. It just depends on how the class goes today. So most of your midterm comes from chapter 5, but I put a few easier problems from the chapters 1 through 4. But y'all, everything we do in chapter 5, we use on those chapters. So nothing is like...
We're going to review when we come back on.
Absolutely. We'll finish chapter 5. We may just do like a little quiz over some of it and then have a midterm over. Because when we come back, we've got 3 weeks. One of those weeks is midterm week. So it takes away from learning, because you're doing testing and stuff. So chapter 5, we will finish it, and then we're reviewing for midterms, and that's all we do when we come back. Anyway, so this is a little bit harder. I will let you have an index card on your midterm chapter 5 test, because it's mostly chapter 5. I don't care what all you put on there. So when we come back, that's something we'll take time out of class. I've got a ton of index cards, and you can write. This is the type of stuff that you would want to write on your index card. If you don't want to write it today, that's fine. It'll be in your book, and I can tell you what page it's on after break. But they use words like concurrency. There's a point of concurrency. Are the things concurrent? Are you listening, Emily? Because I don't know if you can hear me. They talk about the circumcenter of the triangle, a triangle circumscribed around a circle, an incenter of a triangle that is inscribed in a circle. Yes, this is I'm talking geometry. So do you see all these words and how difficult it is, Georgia? Yes, I thought so. All right, I'm going to draw this picture. I have triangle ABC. And I'm going to draw another, I'm going to split this in half and draw this little line. Okay? Does everybody see how I split AC in half and I just drew a line from there that makes a 90-degree angle? Or that's what I'm going for. Now let me do that from each side of my triangle. Let me try and find the middle of BC. Well, we're just pretending it is, right? Okay? And then I'm going to find the middle of AB. And that's a 90-degree angle. So, do y'all see how I found the middle of each of those sides? Yes? This point right here is where they are concurrent. It's, all right? Point of concurrency. I'll write that. Point of concurrency. How do I spell that?
What's it called? People not know that.
Concurrency. All right. So, are these little things equal? Are these little lines that I drew, do they look equal? No, they're not. Look how small and short that one is. That one's longer. It's not about the length of those. It's just if I find the middle of these triangle segments, where do they meet? That's the point of concurrency. Do we understand that? Yes, kind of, no. Okay, so what it says is that these are, I'm going to call this P for point. Is everybody good with that? And then I have X, Y, Z. What I do know is PX, PY, and PZ, they're perpendicular, and they all meet at point P. Does everybody see that? I also know if I was to draw this is where it kind of gets confusing. I'm going to use a different color. If I was to draw these little lines, those little lines are equal from the angles. Do y'all see that? The little lines from the angles, AP, PC, and PB, those would all be equal. But do you see that these three pink lines, those are not equal, right? But these dotted lines are. Are we kind of seeing this?
It's really hot.
Y'all can open a window. I'm not turning the air on, though. Not yet. Not yet. Okay. So, your, let's see. That's the first thing. Then you have, okay, so now we're talking about this circumcenter of a triangle, okay? And I'm using these points that I had shown you before. And I could take that point and I could just draw a circle around it. Okay, anyway, this is what we're looking at. If you have an acute triangle, do you see how this point, this is just like one I drew, is in the triangle? Yes, it's inside of it. Because all of my angles are acute. Does everybody see that? Yes. So if I was to find the middle of these lines and draw perpendicular from them, that point would be in the middle or in my triangle. Not necessarily in the middle of the triangle, but in the triangle. Now, if I have a right triangle, that means it has a 90-degree angle in it. And I draw all these lines. I find the middle of all my lines, all three sides of my triangle, and draw them. Then what happens is that point ends up being on my right triangle. Does everybody see that? This one, all acute angles, it's inside of it. This one, it ends up being on the right triangle. But if I have an obtuse triangle where I have a really big angle, then notice that that point ends up being outside. Okay, so we may find these points, or we are going to find these points in a second. Is everybody good with this? Yes, no, no. Okay, I think it's going to just take some practice. Okay, let me give y'all this sheet and we'll work on this together. From what I just told you, this one, is that circumcenter going to be on the triangle, outside the triangle, or in the triangle?
Outside. No,
on it. When it's a right triangle, it's on it. This one, on it, inside or outside? Inside, because they're all acute angles. I don't have an angle that's bigger than 90. I guess, I don't know. Does that make a 90 degree? I can't tell. It's either inside or on it. We're gonna do all three of these together. Okay, this one, is it inside, outside, or on it? On it. This one I'm not sure. I'm thinking it's inside.
If it's outside.
If it has an obtuse angle. These do not have like a very large, a wider angle. They don't. So I don't see that there's going to be a circumcenter on the outside of the triangle. So what you do is you find the middle, okay, and you draw this way. Do y'all see that was the middle? Because I went up one or down one, and you just draw to where it makes a 90-degree angle. All right? Then on this one, what do they want us to do? Yeah, that's what I figured. Okay, on this one, where's the middle? 1, 2, 3, 4, 5. Where would I go to the middle? At 2.5. So I'm going to go up. So where do they meet? On my triangle, right here. That is the circumcenter of the triangle. If I was to say what that ordered pair is, I would say that it is, what is that, 3.5? Over 3.5 and up how much? 2. I'll say it again. So once I find the middle of that side and draw a line straight, find the middle of this side of the triangle and draw my line straight, that is my circumcenter of the triangle. We already knew it was going to be on the triangle because it was a right triangle.
So like number 2, that looks like.
Well, yeah, we'll find the middle in a second. Okay, so this one, I went over. So here's my starting point, and I go over 1, 2, 3.5, and up 2. That is my answer on my grid. Okay, number 2. Whenever it's got the straight line like this, that's where you're going to want to draw it. So that is the middle. I'm going to draw a line straight through that. Is everybody good with that? Now, if I was to do this one, I'm thinking it's about right here.
That's what I'm thinking. That's not what.
Oh.
That's not what I'm doing.
Huh?
Why are you doing that?
Why did you do that?
I'm just finding the middle of those sides and drawing through it, and it's about right there. I'm thinking it's pretty much on that, though. I think it would be on the triangle.
Wow.
And it does it not look like it's a right angle?
Yeah.
I mean, it does. So I would think it's going to be, like if I turned this way, right here, does this triangle look like it's a right angle now?
Oh, yeah.
Yeah, so I think that's why it ends up being on the triangle. I considered that it was going to be. So then here's another one. I don't know why all these are right angles, but they are. So this one, I would go to the middle. Do we see how the whole thing is 1, 2, 3, 4, right? So I'm going to go halfway and draw my line through it. Is everybody good with that? Then my other side is also 4, right? 1, 2, 3, 4. So I'm going to go over 2 and draw my line through it. Where do they meet? On the triangle right there. That's the circumcenter. And if I was to name that point, I didn't name the other one, but this one would be -2, 2.
So you go halfway on those.
Yeah, you're trying to find the middle. That's what the circumcenter is. Like you're trying to find the middle and draw where they meet. Sometimes it's on the triangle, sometimes it's in the triangle, and sometimes it's outside of the triangle. Yes?
You do number 2 again? I don't know why you drew that X.
I just drew all 3 lines. Yeah, I'll do number 2 again. So, look, I'll do it on I have another paper. What I did was, do you understand how the bottom line is the easiest? So I went right here and I drew a line through it. But now I can't really tell, I need another line, right? To see where they intersect. So I kind of cheated on this one, but I went 1, 2, 3. There's 3 squares, so I went 1.5. Do you see that? And I'm drawing my line through it. And do you see where it crosses?
Okay.
Right there. Now, then I just did it on the other one too to make sure, and it crossed at the same point. But in y'all, this ordered pair would have been 0 and down what? 2. I didn't write that one. Okay. So that's the first part. Those all had 90-degree angles. That wasn't so bad, right? Are they always going to have a right triangle?
Oh, yeah.
Probably not, no. Let's see what our next one is. Pause it. Graph paper, I do have graph paper up there. But number 4, they give us 3 ordered pair, right? What am I going to do with those ordered pair?
No.
I'm going to graph them. So my first ordered pair is 1, 3. Over 1, up 3. Is everybody good with that? My next ordered pair, we'll wait on the train.
See, if you're just graphing,
It's not that loud.
Scott, do not tell her.
What? What'd you say?
Don't even.
I think we do that.
Maybe Jackson didn't open all the windows. Be quieter.
Okay, the next one, the next ordered pair, Hayden, is 4, 3. 1, 2, 3, 4, up 3. Okay. Then my next ordered pair is 4, 2. So I'm going to go over 1, 2, 3, 4, and up 2. And it's this little triangle. I'm going to draw my triangle. Your straight sides are the easiest to use to find the middle part of that side. Okay, so this one, the middle, since it's just one side length, it's just in the middle of it, right? So I'm just going to draw a line in the middle. Does everybody understand that? Question.
Mom said $5.
$5 each. Everybody bring $5 tomorrow.
Can I text my mom?
Yeah, well, I'll send a reminder in a minute. Okay, the next one, look at my next side, y'all. It is a distance of 1, 2, 3. So where's the middle of that one? 1.5. So I'm going to draw a line through that. Do y'all see where they meet?
Yeah.
That is my answer. That's what we're looking for. So this point right here, that's my answer. It would be 1, 2.5, and up what? 1, 2.5. Does everybody get that?
Yep.
2.5 and 2.5. Let's do another one. Are we liking this?
I don't really know. I don't like drawing the lines in them.
Yeah, well, that's part of it. That's how you find it.
I
Okay.
know, obviously.
Now, the next one, let's look at number 5. Oh, do y'all have? Yeah, you have your paper.
For number 4, is that all you put?
That's it. That is your circumcenter of the triangle. Number 5, we have the point over 2, down 3. That is the longest train ever. Over -4, down 3.
Should be there when it's.
-4, down 7.
Y'all hear that train when you go to sleep?
What?
At my house, no. Annalise used to sometimes when she was younger, and it would scare her at night, but not anymore. I don't think, I never hear it. In the winter sometimes, because the trees, have all the leaves are gone, and so I think when it's summertime, it kind of creates like this, I don't know, blocks the sound. So, but in the winter, if it's really cold and the wind's blowing that direction, sometimes I'll hear it at night. But anyway, this one, here we go again. What am I going to do with each side of the triangle? I'm going to find the middle of it and draw a line through it, right? And all you need to do is find 2. 2 lines will give us a point. So I'm going to 1, 2, 3, 4, 5, 6. So I'll count over 3. 1, 2, 3. I'm just going through half of it, right? Is everybody good with that line? Now I'm going to find my other one. It's a distance of 1, 2, 3, 4. What's half of 4? 1, 2. And I'm going to draw a line through there. What did I do wrong? Oh, I know what I did wrong. I didn't draw a good triangle line. That's why. It should be on my triangle. How did I know it was going to be on my triangle?
Right.
Because it was a right triangle. It had a right angle. Okay, what's my answer? That ordered pair right there. Okay, are we getting this? Yes, it's not bad. Let's skip and do one more. For some reason, all these are right.
What's the
Be 1 negative.
Oh, the point is -1, because I went to the left 1, and then down how much? 1, 2, 3, 4, 5. So it's -1, -5. That would be my ordered pair.
That's number 5.
That is number 5. Let me skip and do one more. Let me just pick number 9. All right. Number 9. And then I think we'll do the bottom part of this worksheet, and then we'll finish the back part on Wednesday before our quiz. Okay, number 9, over 2 and down 2. That's that order pair. To the left 4 and down 2. Right there. And then to the, this is just like the other one. Left 4 and down 7. I mean, it is just like it. Another right triangle. Okay, I kind of missed that a little bit. Oh well, it's okay. So I would find the middle. 1, 2, okay, hold on. 1, 2, 3, 4, 5, 6. So I'm going to go over 3. Draw a line through it. Okay. Then on this one, what's my distance? 1, 2, 3, 4, 5. So where am I going to go? 2.5 and draw my line through it. And my triangle should go through right there. That's my point. Do we get that? Yes? Yeah. I didn't draw a straight triangle. I mean, that was my fault on my drawing. Okay, so that's the same thing over and over. That whole first half on the front is just drawing the triangle, figuring out halfway and where they meet. That's the circumcenter of the triangle. Now, I think I've gone through point of concurrency. Let's see if we can figure these out. I think I've gone through this part. Yeah. All right, it says name the point of concurrency. There are several like this on your test, okay, whenever it comes. The point of concurrency, they give you different points. What is it?
P.
On number 12, it is point P. Does everybody see that?
So I try P.
So you would write P. Point P. Yeah. Let me see what else. All right. The next one, what's the point of concurrency? This one's the one where they kind of give you several points. Is it H, I, or J?
I.
How did you get that it's I?
It just looks like it.
It just looks like it.
That's a good answer.
I ain't even gonna lie, Smooth. I ain't gonna-
For your, and it's look, which one is the angle bisector? Because read your directions. Name the point of concurrency of the angle bisector. Where did it which one of those bisected an angle? I did. Yeah, that one right there. It also looks like
Does not the two lines have to touch each other?
J could have, but then it needs to be where there's also this 90-degree angle. Do y'all see that? But that's not I, that's G. Hold on. That one has the angle bisector. That's going to be I. And then this one has the angle bisector, which is also what? I. That's why. I didn't mean to say G. Okay. Number 14. Where are your angle bisectors? Okay. So it looks like it could be this line right here and then this line right here. And where do they meet at? W. Okay. Are we getting that? Yes. Let's see. Look at 15. Where the point of concurrency of the angle bisectors. Which one is it? It's good to draw through it.
W.
On number 15, there is no W.
We're talking about 14.
Number
Yeah.
15.
It's F.
We were talking about 14.
Sorry. Yeah. But we're on
I know
15.
we're on 15. I was talking to Will about 14.
Oh my gosh.
Dear Lord, does nobody understand what I'm talking about? I know we're on 15. I know what we're on. I know we're not on 15. I mean, I know we are on 15. Oh, I know.
Number 15 is F. Why is it not H?
Because it's not
the
H doesn't intersect that other than U.
Yeah, so H is kind of where this perpendicular line is, but it's not where these angle bisectors meet, okay? They meet at F. Where does, on number 16, where do the angle bisectors meet at? N. I think that's the only one. Yeah. And then on number 17, the angle bisectors meet at what?
S. Maybe.
P.
P.
Yeah.
P. Look, because S is, S is this one right here, but it's not an angle bisector because M doesn't have the marks to show that it's an angle bisector. Okay, let me see what else I might want to say for today on the recording. So circumcenter, we found the middle of the side, draw the two lines, it's where they intersect. Then the concurrency, I forgot to show you this. The concurrency of an angle bisector, it has nothing to do with the 90-degree angles. It has everything to do with where are the angles equal. That's the point they meet at. So that's just another term. I think that's enough terms for today. So what we're going to do on Wednesday is kind of go over this, finish our last type of problem, review for our quiz, and quiz. Okay? And that's all we have for Wednesday.